Okay, hello. So this is the final section of 4.5 that we're going to do. So this specifically is where we are calculating our D value. Okay, so we've so far done A, B, and C. We are now going to go with a D value. Super off center and bothering me. Sorry about that. So what happens with a D value is we get what's called a vertical shift. Okay, so yesterday we did more of a horizontal shift, so we shifted left and then right. So with this D value, we are instead now going to shift up and down, depending on the value of that D value. So what changes is instead of where our first, like yesterday was, we shifted where the beginning period started. So that beginning period would either shift back or it would shift forward. Now we are actually changing where our center line is. So, I don't know why I'm so off center. Sorry, guys. So we are changing where the center line is, i.e., this is kind of the x-axis, right? The x-axis is the center line of our graph. We change where that is. We're not going to shift the actual x-axis. That will never shift, but we shift where we act like it is in our graph. Okay. So the easiest way here is to go ahead and get into an example. So we are going to do first y equals 2 sine of 2 sine of x minus 5. And one other thing I forgot to tell you is we're finally at like the overall function here. We've added an A, a B, and a C. Now we can finally add in our D. So what this would typically look like is y equals D plus A sine bx minus c. I'm so off center. I'm so sorry. Also, y equals D plus A cosine bx minus c. One thing I just really want to point out is this D can be in front added on or in back added on. So let's show you a different representation. It could be y equals A cosine bx minus c and then a plus D here out in the back. Just that plus D out in the back. Okay, you can kind of see that going on out there. So what's happening is, gosh, my mic's camera's falling off. Okay, there we go. So what's happening here is that D can just be shifted because it's added on as long as it's outside of parentheses. If it's inside of the parentheses, it's a C value. If it's outside of parentheses, it's a D value. If there's no parentheses, that just again means it's a D value because it's outside. So when we're trying to graph this, of course, we want to identify our A, B, C, and D now. So A equals 2, B equals whatever's out in front of this X. So that's a 1. There's no parentheses here. Again, if it was a C value, it would be attached to the B and the X in parentheses. So since there's no C value, that C value is actually just 0, right? Because we're adding on nothing. And then D is a -5. So this -5 means that we are going to shift down 5. Okay, again, a negative, that means we're shifting down. So let's draw this up. So if we're thinking amplitude, that would have meant that we would have went up 2 and down 2. Okay, so we want to think, where is our normal center line? We can label this out. 2 pi, pi, 3 pi over 2, and pi over 2. So a normal sine function is going to start here, go bam, 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 and just keep going on. But with this vertical shift, Okay, we're taking this center line and shifting it down a total of 5. So we have to go down to -5. What I like to do, and this is not to confuse you, I like to put a dashed line here. You don't have to. I don't want you to get confused with the fact that this is an asymptote, because it's absolutely not an asymptote. This is now my new x-axis. Okay, and again, take this new x-axis term very lightly. It's not literally your x-axis, but what we did was we shifted where the graph treats our x-axis. Now it treats it like an x-axis down here. Again, we would have had here, 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 and now that's all happening around this line. So you will not have your curve happening up here. It's going to all be focused around this center now new line because of our d value. However, our amplitude still stays the same. So I still have to use this line to go up to -3 and down to -7. So while our middle line might change, our amplitude does not. Okay, so if we did a normal sine function, again, we would start here. Since we have no c value, we do in fact start there. And again, we start down or on that middle axis. Now we get to go up to, back to our center line, down to, back to our center line. So we go like this, and we could just keep that path going, right? Again, I don't like you to get into the habit of just stopping after one period. If it's not done, it's going to continue on forever. Okay, little bit difficult, more of one. Okay, nothing too crazy, just one more kind of different example of one that you might see. So this one is y equals, let's do 3 plus 2 cosine 2x. 3 plus 2 cosine 2x. So as always, start with identifying. So our A value, here's our amplitude, which is 2. Our B value is in front of our X. Right now that's a 2, so B value is 2. I'm going to stop right away because I know I have to find a new period now. My B is not 2, or my B is not 1. So that is 2 pi divided by B, 2 pi over 2. My new period is pi. What do we know about when we start graphing this function though? I need 4 intervals. So I divide this pi by 4 because I know I need to divide this pi up into 4 even intervals. Here's where I'm going to stop. Here's where I'm starting. To divide that up into 4 even intervals, I just exactly divide pi by 4. That means that this chunk is pi over 4, this chunk is pi over 4, and this one are both pi over 4 individually. So I can truly just count straight up. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Again, you can simplify this down to pi over 2. So now I need to figure out what else do I need to find? My C and my D. C value, nothing in parentheses being added on. So again, 0. We're going to take it easy on you here right now. D value this time is added out in front, and that is 3. So again, what this means is let's go up to 3. I've now shifted my entire graph up by 3. So while my amplitude is still 2, so again, I need to go up 2 and down 2 from this line. My actual center axis is at 3. So when we know about a cosine functions start up at their highest point. So I will start at 2. My next line should be on my axis, so it's going to be on 3. I come down to my lowest point now with this third one. So my lowest point's only going to actually be at 1, right? Because that's 2 off of my center line. Back up to my axis, and back up to my top point. So we can assume it takes this nice, I did this way too low, so sorry. That's why you don't guesstimate first. Continue on and continue on. So that's another thing that I should touch on. It's important that when you are continuing these on, be as accurate as possible. Look how on this one, I just went way down here. My graph doesn't actually do that, so make sure you maintain these as accurate as possible. Okay, that is it for D values. Keep in mind, you can have all 4 things happen at once. Truthfully, all 5 things. You can have an A value, changing your amplitude, a B value, changing your period, a C value, creating a horizontal shift left or right, and a vertical shift up and down, while possibly even having a negative A value reflecting your graph. So all 5 things can happen at once, or 1 thing, or 2 or 3 things can happen at once. I try not to throw all of them on you at once, because imagine if we also had shifted this up and to the right. That would have been kind of confusing to kind of get your bases on that. But this is the whole gist of what you will see with a D value.